Now let's look at 2008, question 5, part A. This is a elegantly simple question, which is kind of a nice bit of revision in looking at this topic. So what we got is we have three spheres, and so elegantly simple they don't even give them names, but I'm going to call them A and B and C just so we know what we're talking about. Lying on a smooth table, the first one comes in at speed 2 meters per second. These two are stationary. This hits this hits this, and we need to find out their speeds in terms of E, and show there'll be at least one more collision. So let's lay this out. So first of all, collision 1 is A into B. All right. Our initial speeds are going to be, actually this is so simple we can kind of go straight into this one really. Our Newton's law of restitution is going to be V1 minus V2 over U1 minus U2 equals minus E. So in this case, well, we've got V1 and V2, so V1 minus V2, and that is going to be 2 minus 0 equals minus E. So V1 minus V2 equals minus 2E. So that's our first equation. Principle of conservation of momentum is the second place we're going to go. Now all of our masses are equal, so this becomes a whole lot easier, which is rather nice. So we are going to have the initial speed of sphere A. Of course, B is stationary, so that's a 0. And V1 and V2 are final ones. So there we go. Cross out all the masses, and we end up saying 2 is equal to V1 plus V2. That's equation 2. I have a minus V2 here and plus V2, so we just combine 1 and 2. That's minus 2E equals V1 minus V2. Those are going to cancel out. So I get 2 minus 2E equals 2V1. So I'm just going to flip this around. So V1 is 1 minus E. Okay, there is my first speed in terms of it. Then we want the second speed, so V2. Well, let's figure out V2. Here we go. If I rearrange this, V2 equals V1 plus 2E. Sub in V1. Therefore V2, there's V1. 1 minus E plus 2E, so V2 equals 1 plus E. Okay. Two of my speeds. They wanted after two collisions. The second collision, of course, is going to be B hitting C. So we'll come up here for a bit of a fresh start on this one. Collision 2, B into C. All right, now it is getting a few more bits going on, so we're just going to put down the U of B, U of C, just sort of get clear in our velocities and our terminology. So the initial speed of this one is of course going to be V2, and that is 1 plus E. C isn't moving initially. Then the velocity of B after this collision, we are going to call that one V3. And the velocity of C we're going to call V4. Now, it's always worth kind of getting clear on these things, otherwise you can trip up yourself and make some simple mistakes. Okay, so now, into the same old thing, Newton's law of restitution. Well, V1 minus V2. Well, in this case, we'll jump forward from the initial thing just to save a little bit of space. V3 minus V4, bring our values in straight away. 1 plus E minus 0 is minus E. Okay, so this is going to get a little bit funkier. V3 minus V4 equals minus E factor of 1 plus E. Okay, we'll leave it like that for the moment. We'll worry about it later on. Principle of conservation of momentum. Well, factor of 1 plus E. Second one isn't going anywhere. mv3 plus mv4 So I end up with losing my m's. 1 plus e equals v3 plus v4. So this is going to be equation 3, and that is equation 4. Can we combine them? Yes, we can, straight away. Bring 3 over here. So this is, I'll actually multiply this one out just to keep it tidy. That is minus e squared. Okay, v3 minus v4. So it's going to be a little bit easier to combine. Minus e squared equals v3 minus v4. Combine them together. So what have I got? I've got 1 plus e minus e squared. 1 minus e squared equals 2v3. So v3 equals a half 1 minus e squared. Okay, that's a little bit uglier. So that is, of course, one I was looking for. And the last one we need is v4, which is the least awful way to go at v4. Let's have a little look at it. Sub in v4. There's no point getting too worried about it. So v3, sub in, now this is why we use our values. Sub in, let's just actually tidy all that up first. I want v4, so v4 equals v3 plus e squared. Okay, subbing in v3. Therefore, v4 equals, I'll split these guys out, equals a half minus e squared over 2 plus e squared. So v4 equals a half plus e squared over 2. Now if I'm looking at that one, I can see that this is actually rather closely related to squares. So let's rearrange this a bit. Pull out the half. 1 plus 2e plus e squared, and that equals half factor of 1 plus e all to be squared. Just easy enough to recognize. So after each collision, after 2 collisions, VA is going to be up here, 1 plus E. VB is going to be V3 over here. It's a half 1 minus E squared, and VC is a half 1 plus E all to be squared. Okay, so let's look at our final little bit of one. We need to show that there'll be at least one more collision. Now, of course, double checking, we have a small little mistake there. That is, of course, 1 minus E, because V1 was VA. Okay, and in hindsight, would have been no harm to written that table. Now, for part 2, we're going to go over to a fresh sheet of paper. So, part 2, will there be one more collision? Well, we have our 3 balls in a row. This one has hit this one, A, B, and C. B has hit C. B slowed down in the collision from B to C. So our other collision will be, it'll be A hitting B. So B will have slowed down enough that A catches up on B. So therefore, the velocity of A will be greater than the velocity of B. Now we've got to prove that. Well, let's bring our values in here. Okay, so the velocity of A is 1 minus E. The velocity of B is a half 1 minus E squared. All we got to do is prove that that has to be true. So let's start breaking things out. 1 minus e, well actually we'll double them up here. So let's say 2 minus 2e is greater than 1 minus e squared. We can now lose our 1's, so that becomes 1 minus 2e is greater than minus e squared. Bring the e over here. So e squared minus 2e plus 1 is greater than 0. Does this look familiar? Well, indeed it does, because it's e minus 1 all to be squared is greater than 0. This is true.